Hello, everyone in Portugal or wherever you find yourself for this uh, wonderful presentation called Next Stop Event Bus. I am Robert Raposa. I have been with edX, which is now a part of 2U, for over 6 years. And here's what we're going to be talking about today. So, we are going to be talking about the event bus and adding an event bus to edX platform, or to, sorry, the OpenEDX platform. And we'll start off with getting on the same page about what an event bus is. Then we will talk about misstops, which represents what we've done when we haven't had the event bus and what things might look like if we did. Then the bus depot is where the event bus happens to be at this moment, and we'll discuss things that are being worked on now, and then next stops. Once the event bus leaves the station, where are we headed? Starting with the event bus, or an event bus. So first, brief definition of an event. An event represents something that happened in the system. I want you to pay attention to happen. That is past tense. This is a thing that has already occurred, and it is not a way to ask another service to do a thing. It's simply to say, hey, this thing happened. So an event might be the user enrolled, or the user's grade changed. And some additional details about an event are: an event gets triggered at a particular time. User enrolled should get triggered when a user actually enrolls. And then an event can be represented with related data. So a user enrolled event, you could imagine, would have information about the user that enrolled and about the course that they enrolled in. Now let's look at a diagram that you may see elsewhere in documentation if you look through architectural documentation for the OpenEDX platform. This is a drawing that includes the event bus. So we've got microservices up there. Some examples in the OpenEDX platform would be the LMS or Studio or e-commerce or discovery. These are all microservices. For those of you in the know, the LMS is actually not a very microservice, but for now, the drawing has everything as a microservice. Then you have the idea of events being fired or published from an individual microservice, an event being what we just discussed. And then it would head on over, it would be published to the event bus, and from the event bus, one or more microservices could then read that event, or consume that event, actually, and do whatever it needs to do based on the event that was consumed. We will go into much more detail around this, but it's just a high level of the way the event bus can work to help communicate asynchronously these events across services. So let's look at some misstops. We do not yet have an event bus as part of the platform, so what have we done? Let's look at first case study. These are grades or grade changes for the credentials service. Let's look at what this looks like. So from a high level, LMS is where the service where users are interacting when their grade actually changes, and you can imagine the grade gets changed after a user takes an exam or something like that. And then you've got this credentials service that wants to grant credentials once you've got a passing grade, and it's like, hey, do I have a passing grade? Yay, let's grant you a credential. Now, this could be a stepped back high-level perfect drawing of what I just described and what we want. It could also be a drawing of, or a diagram of a synchronous API call. You can imagine, oh, the user's grade changed, and as soon as it changed, we make this call over to the credentials service. The user's sitting there waiting, and so we have, I may refer to this a bunch of times, what's called the architecture manifesto, which provides a bunch of architectural trade-offs and the direction we'd like to lean. So one of them is in the direction of asynchronous versus synchronous. And so if we imagine this to be a synchronous call, it is not something that we want, because then the user is waiting and waiting and waiting. The credential service is down. We've got problems. And I've seen domino effect of several services falling in a row because of things like this. So that's not what we have. Let's move on to something that's closer to what we've actually implemented. So what we have is, the LMS notices that the user's grade changed, and what it does is it spins off an asynchronous task on what I'm going to call here the LMS worker. Behind the scenes, this is Celery is the technology that's used for our asynchronous tasks. And in there, the worker task is what actually makes that call over to the credential service. So we've got some improvements here in terms of what was designed. We now are actually leaning into an asynchronous call from the task, so that the user can get a response immediately. We talk about leaning into eventual consistency. So rather than having all the data in the system being consistent all immediately, if the user actually needs to have a credential granted, it may take a little bit of time. And if their UI is checking that, it might look like it's not granted yet, and then later look like it's granted. That's what eventual consistency is. But it provides for a much more responsive experience. Then what else do I want to say here? So we've got definite improvements on going towards asynchronous. However, we've got still some issues here. So the issues I'd like to highlight is, one, we've got tight coupling between the LMS and the credential service. So the LMS needs to know that the credential service cares about grade changes and needs to call the credential service, even though it's calling it asynchronously. Additionally, if the credential service is having, problems, whatever, is getting upgraded, it's all of a sudden, it's now the LMS's problem and concern as it's trying to deliver data over to the credential service. And we've had, a variety of not so resilient communication going on in a setup like this. This is a common setup that we have right now in the platform. And I'd like to add one more detail of what we have. So because that communication is actually not so trustworthy and resilient, the developers who implemented this decided, if we send every single grade over there, even though it's not a grade that the credential service actually is going to care about, or a grade change that they don't care about, we're going to have a lot more data going across. And because this is not a really reliable way to communicate, let's add credentials code into the LMS code that basically is filtering down to the grades that credentials cares about, and then only send those over to the credential service. So now we have credentials business logic bleeding into the LMS. We've broken what is referred to as a bounded context. So you can imagine a nice boundary. Bounded context comes from domain-driven design, and you could imagine a nice boundary around the credentials service with engineers wanting to, care more about the credential service and less about services that they don't care about, both while implementing and then even while operating and maintaining and observing. And because of the unreliability of this, we now have broken that, and people who are working on the credential service also have to pay attention to the LMS. People who pay attention to the LMS have to be concerned if credentials is having problems. So what might this look like in the world of an event bus? So let's take a picture like this. So here we have the LMS has this grade changed event, and it publishes it to this new infrastructure that is the event bus, that is set up purely for having events published to it and allowing others to consume from it. So this grade change event goes to the event bus. In theory, the event bus is reliable enough where we actually may be able to call it and should be able to call it synchronously and treat it more like a database or something like that. Time will tell. We're working out the details of this. And then here we have a picture of a credentials consumer. So it's still sort of within the bounded context of credentials can actually, the way we're working with it or thinking about it right now, it has all the credentials code, can connect to the credentials database, but it is a separate process. And it's the purpose of this process, this particular consumer, grade change consumer, is to consume those events as they come in. So if the consumer is having problems and isn't around, it's just not consuming. It's not hurting anyone else. And when it's doing its job well, it is consuming events off the event bus. So, so the reliability of the communication across from one service to another should be much more reliable. In addition, we were talking about the tight coupling between the LMS and the credential service before. Now you've got what's called loose coupling, where the LMS is publishing a grade changed event for anyone who may care about it. And it doesn't know and doesn't care that the credential service does care about it and is consuming it. It also wouldn't know if yet another service decided like, oh, I've got a great idea of how to use these grade change events, so I'm going to build a consumer and consume it and make some new functionality off of that. So we've got a lot of nice benefits around the loose coupling and, again, the bounded context of only having to care about the service that you're working on when it comes to both development and operating. So, quick coverage of that. Asynchronous requests and eventual consistency. These are two things, trade-offs that we want to lean toward and that we have been leaning toward. But the last two, clear bounded context and loose coupling, are also trade-offs that we want to lean towards, but we have been unable to without the event bus. We've had problems as just described. So next case study is the discovery course metadata refresh job, actually. So let's talk about this. Here we've got Jenkins, which can help run scheduled jobs at different times, and then it is calling the course discovery worker, which is again an asynchronous task within the context of course discovery service. And that is a really large job that reaches out to a variety of services. These arrows are actually in the direction of the flow of the data, but not of the reaching out. So the course discovery worker is reaching out to the LMS and the e-commerce service and saying, hey, I've got requests for a whole bunch of batch data. Give it to me. I'm going to load it and load it into my own database and do some nice data redundancy so that I can have it available in the way that I need when I need it and give faster responses to the users and be more resilient to problems if you're down when I'm trying to respond to a user. So data redundancy is another architectural trade-off that we're leaning towards that helps in terms of keeping these separate bounded contexts. But the way this job is set up, we've got a lot of latency. We've run this job, I think, just a couple of times a day, and potential problems because it's, very large and has to deal with this communication with a bunch of services, and they all have to be available at the same time. So what might this look like with an event bus? This one is much more hand-wavy because this job is quite complex, and I'm not sure exactly how this would play out. But theoretically, it would be more of this sort where LMS and e-commerce have certain events that they could publish to the event bus. They don't know who's going to consume them. It happens to be the course discovery service here, but it could be one or more, or future services that decide that this is important data to them. So again, we've got the loose coupling, we've got the data being sent as soon as it's changing. So we've got, even though we have eventual consistency, we have relatively low latency on the changes of the data in course discovery, assuming that the consumer is up and consuming this data pretty close to when it's being published, which is different than a couple times a day. So for review, we've got data redundancy. We're not really changing that. We were leaning into that before and after, but we've got this architectural goal that was stated in one of the documents that I'll talk about later, and to eliminate expensive delayed batch synchronization. So this is a goal that the event bus and asynchronous messaging can really help us with. Now, let us talk about the bus depot. So where all the buses are, we're working on the bus, and I'm gonna give some details of what that work looks like. So it started off in 2021, but actually well before that, with this OEP 52 on event bus architecture. And OEP stands for OpenEDX proposal, and so this is a decision record about details around the implementation of the event bus and different ideas that we have. And originally, it was pretty dedicated to looking at different technologies and sort of choosing one to move forward with. And that actually got moved off to a separate architectural decision record. And we chose Kafka at this point for edX. And what became clear is that the larger community may or may not want to use Kafka directly. So we talked about and have talked about and including an abstraction layer so that multiple technologies could be used ultimately for the event bus part of the infrastructure. So a couple of things here. Anytime I say we decided this OEP is in a draft state, and all of the architectural decision records where we made decisions are all provisional. So we're very much working on this now, seeing how everything plays out. And Yeah, so now let's go a little bit more into the abstraction layer. So here is another piece of a diagram that you may see in other places. And what this is talking about is how events work within a microservice. So once again, they're allowing for this capability of loose coupling, where an event, whoever is sending the event, doesn't necessarily know all the people that are consuming the event. The way that works within a microservice or a Django-based service is by using this technology called Django signals. And signals are sent and received. And the sender of the signal doesn't know and doesn't need to know about the receivers of the signal. And you can see the receiving on the right-hand side is actually happening through several plugins. And so these plugins can be written where the service doesn't know that the plugin is going to appear in it. It's plugged in at a later point in time. It's extended in that way. And it doesn't know that the plugins are going to be listening to receive these signals or events that are happening. So it's nice loose coupling. I do want to mention, just in case, that that this is all happening, the signals are all happening synchronously though within the microservice. So when these plugins actually want to do any sort of work after receiving the signal, it really still needs to send off an asynchronous task to the worker of the microservice. So I just wanted to mention that. And this, you can learn and read much more about this if you read up on the hooks extension framework. That's partly what's being described there, is what I just went over. So, although there's much more to that as well. Here is a zoomed out picture of the same, but now you've got the same microservice several times and connected to the event bus. So the idea here is that these events that are being used, or these signal events, let's say, that are being used to communicate within a microservice, I like the head spin that represents the event, within the microservice is now getting published out to the event bus so that it can be consumed asynchronously across microservices. And in theory, as part of the abstraction layer, that same signal-based event definition is what we're using to send across the event bus, send into another microservice, and in theory, even to send that same signal again within the other microservice. These signal events, well, let's talk about that in a moment. So OpenEDX public signal is the class that represents a particular signal/event definition. And this exists within the OpenEDX events repository. Again, there'll be links available at the end. And there's a bunch of event definitions that exist in there, including the kind of event that we went over before, like grade change. Not sure if that one's in there yet or not, but that's where it would go. So the rest of this is more details about sort of implementation and how it works for the picture that we were just looking at in terms of getting this OpenEDX public signal event over to the event bus and consumed by other services. So schema evolution is the idea that once you define an event and start publishing it and consuming it, at some point you're going to say, you know what, I'd actually like to store a little bit more data with that, pass a little bit more data around. So that the idea of that, a change in the schema, is called evolving the schema. And there's a variety of tools and practices, like a schema registry, that can help you evolve your schema safely. Safely as in, you're not going to make some change where all of a sudden consumers are going to start consuming the event and say, just exploding and going, I can't deal with this event, I can't deal with this event, and it's all because you changed it in some way that that's not allowed. So these tools are quite important, especially when you get to publishing these across services and relying them on these events in multiple services. So next we have a provisional decision that was made to use the Avro schema to help with the schema evolution. And this Avro schema format is a popular one with Kafka. It used to be the default, but it's still recommended by a bunch of experts. So we decided to make use of the Avro schema format. And what does that actually mean for us? It means we're working on currently this Avro signal bridge. So what that does is it takes the signal, this OpenEDX public signal, which represents an event within a microservice, and it can automatically take that definition, convert it to an Avro schema, and then that Avro schema can be used to serialize and deserialize a particular event instance to go onto the event bus, and then deserializing it, taking it off the event bus, and providing it so that it can be consumed by some other service. Next thing that we've been working on related is an enterprise use case POC, or proof of concept, where we're just publishing an event from one service and consuming it and just simply logging it in another service. We have that working. We have that working with our Kafka deployment that is currently on the Confluent cloud. So Confluent is a big third-party deployer of Kafka, and we've decided to make use of them and their expertise to not have to host it for ourselves. And Confluent they've got a lot of engineers that help develop Kafka and continue to help develop Kafka. And that's a decision that's documented, and people can follow suit or not follow suit as they wish. We're just providing details of what edX was doing. Also, in terms of deployment, we decided to do a Kubernetes deployment of our consumers by implementing a container in Kubernetes, and you could read more about that in documentation. And then, as I noted earlier, all that bridge work for going from a signal to Avro and to Kafka and back, that is currently in progress. So what are the next steps? So assuming both in terms of wrapping up the event bus and getting it out there, what do we have to do? So we have a more real enterprise use case that actually is across multiple services. I think 3 services are involved, and we're working on implementing that with the enterprise team. When I say we, I'm part of an architectural team at edX, and so we're sort of jointly working on this right now. We've got a bunch of sad path work to do, very sad. So what does that mean? That means we haven't really dealt with error handling or retries, or what's called a dead letter queue. So a dead letter queue in the event bus world or messaging world is hey, I've got a message that really ain't gonna work for some reason. Tried and it's got some weird error. So I'm going to put it into the dead letter queue to unblock more messages to be able to come through. And we want to work on those all within the context of a real use case. Then we have these production operation work. So we've got, looking into security a bit more, looking into observability and monitoring and potentially scalability and scaling out those consumers if needed. And then we'll have sort of some more exceptional work, like PII is personally identifiable information, because in Kafka, these are immutable records that are going to live forever. We don't really want personally identifiable information in there. Or if we do, we need to think carefully about how that can get solved. I think in the short term, it's just going to be avoiding that for these use cases, and then coming back to that. Onboarding docs. So we need docs for, engineers and docs for operators about how do I do each thing? How do I consume new event? How am I going to add a new event? How am I going to publish a new event? All those goodies. And how am I going to deploy a new consumer? So we need some documentation and abstraction layer. So I mentioned some about the abstraction layer with that whole OpenEDX public signal class and how the signal events work. That's assumed to be a big part of the abstraction layer, and I don't know that that's going to be all of it, and we're going to have to work out additional details as we go. But first, you need to get it working with one technology before you can necessarily make it work with many technologies. So once we have that, then there's the next stops, which is an event bus Kafka alternative. So again, in the OAuth, some members of the community were really hot on alternatives and not wanting to necessarily use Kafka. So the idea behind this is actually having the community do the little bits of layers that would be needed for an alternative technology, hoping that a lot of the work will be embedded in the abstraction layer, and the bridge that I talked about earlier. So hopefully this work will be somewhat minimal, but there's still, deploying, hosting questions, all kinds of questions to be answered. So this will probably lag by 1 to 2 named releases, but we shall see. And then continuous learning and improving, which is, this is all new. So we're not sure what's going to happen. We know what we want to get out of this. We're excited about the potential benefits, and it's a new piece of infrastructure that we need to figure out how to make the best use of. So that's what will be next after that. So to review, we got on the same page about what an event bus is, both how things have worked or been put together while we didn't have an event bus and how it might actually look with an event bus, the current development that we've been doing on the event bus itself, and what's coming next for getting this out into the platform. Got a bunch of resources that you'll be able to get to at a later time, and now we're going to be going to a live Q&A, or if you're unable to ask a question now, you can always go to the OpenEDX Slack instance and tag me and ask me a question. We'll get you into the right place. So thank you so much for joining me, and signing off. Take care.
Let's thank Robert for that excellent presentation on the state of the event bus for OpenEDX. Robert, do we have you on the line there for questions?
We do. We do.
All right,
Can you hear me? Yeah.
loud and clear.
All right. I did also want to mention that Finial is also open to answering questions afterwards if you don't get to the question here. So if you want to follow up with someone in person in Portugal, you can talk to Finial.
All right.
Thanks.
Hey Rob, good to see you.
Good
Um,
to hear you.
Thanks for this presentation. I wondered if you could give us a glimpse, like a foretaste of what the abstraction layer API would look like, because I feel like if we want to prepare for the integration of the event bus in the OpenEDX community release, then we need to figure out what the API is going to look like, and whether we should go full speed Kafka or something else.
I think you're muted,
Uh,
Robert.
I'm I'm muted.
You're good now.
Okay. Um, so I'm not sure how many details I can provide right now, but I do expect it to be relatively simple from a like publishing and consuming side. You know, we're not looking at much more than like publish and consume, but we haven't gotten into the error handling. I don't actually know how it's all going to play out yet. But we also know that we're going to have to give as much advance notice as we can. So once we, yeah, so there will be more on that as soon as we know. Yeah.
Are there any other questions for Robert? Oh, we got one in the chat. Uh, so, question for Robert. Thanks for the presentation. After the event bus is in place, has 2edX thought about updating insights to have streaming analytics?
Good question. So I would say that is not yet one of the use cases that have come up internally to my team, but I really we've been at a place for many years, I think, where we don't have an event bus. We don't have the capability within the platform. And it's been something that lots of people have thought, oh, this would be useful, but I don't have the time for a product feature team, let's say, to actually be able to invest in making this happen so that it's available. And I'm hopeful that there will be lots of use cases, including things like this, where once it's actually ready and available, and if I'm building a new thing or potentially refactoring something, um, it there will be so many more opportunities once it's actually ready versus like an idea of something that we might have. And I meant to, and I may put out a OpenEDX discuss thread around this, but not only am I not clear on all the use cases internally, but I'm not clear on all the use cases from the community. I'm not clear of any of the use cases where people are like, oh, I can't wait for an event bus because of, oh, we could update insights to have streaming analytics or whatever it might be. So more on that as the event bus actually becomes available.
Are there any other questions? May I ask a question?
You can. Oh, also, you can remind me to give some small updates after your question.
Certainly. My question is, do you see this being used between LMS and CMS, or do you think it'll be exclusively for the other services?
No, I definitely see that because I look forward to the time when LMS and CMS are actually two separate services and would require something like this to communicate to each other. But in the short term, probably not. But I don't actually know. And I don't know if it. Yeah, I haven't thought enough about that. But it definitely could be a piece of the potential plan for splitting LMS and CMS for real.
Makes sense. And did you want to add some additional updates?
These are somewhat minor updates, but one is like on the bridge. So I mentioned the bridge a couple of times, which is the whole going from this public signal event definition to Avro and onto the event bus and back. In the next coming days, the bridge is going to be renamed and it's not going to be the bridge and is going to be have new names and have a couple of different parts. So all of this is actively under development and changing as we speak. So I just wanted to note that in case you ever go back and look for this and you're like, oh, where did the bridge go? Or where's this bridge thing? And also even the use case, we may be investigating a slightly different initial use case. So we will see.
All right. Do we have any more questions for Robert? Anything in the chat? All right. Let's hear it for Robert.
Enjoy Portugal.